This is the last video for the history, and I'm going to be talking about cognitive psychology paradigms. It's going to be a little bit longish because I'm going to go through all of these in one video. So we're going to start with the information processing approach, which I already introduced to you a little bit, but we'll go into it in a little bit more. Now, like I said before, the information processing approach actually is making an analogy between human cognition and computer information processing. And so what this means is that cognition, when you're cogitating, you're engaging in cognition, you're sort of seeing it with this approach as information passing through a system. This is basically rooted in structuralism. That was when we were looking at the little episodes, the elements, the smallest elements of human thought. And this sort of an approach of looking at cognition, each of the individual components, and how does information travel through a system, it comes from structuralism, ideally. And in the information processing approach, when you're actually engaging in this sort of an approach to examining cognition, you're going to be using experimental and quasi-experimental techniques. So this information processing approach, this is a more thorough information processing model. And like I said, this cognitive textbook, like pretty much all cognitive textbooks, especially the first chapters of it, are kind of set up with this information processing approach. There are other approaches, as we're going to talk about, but this is still a very strong one. So you've got multiple memory stores. Sensory store is a very, very short term, like seconds, maybe not even a second of delay. And then it moves information to short-term store. You've got pattern recognition. You've got this long-term storage area, rehearsal, all of these different things with attention going through each of these things. And so it's kind of thought of as the mind as a computer with storage bins and memories and things like that, and then processes that move information from one storage bin to another, do things with it back and forth, and then things that are affecting the processing of it. Another assumption of the information processing approach is that cognitive abilities are basically systems of interrelated capacities. So deciding what a movie to watch, taking notes in class, making a joke, lots of different processes are operating to perform any given task. So when you take notes in class, you need to process the information the professor is saying, which involves language comprehension. You need to read the PowerPoint slides, which involves reading ability. You need to decide which information is important enough to write down, which involves both reasoning and decision-making capabilities. You need to remember all of these things long enough to write them down, and that's going to involve short-term memory. And you need to divide your attention between these tasks, which involves about how automatic any one task is compared to another task in your attentional capacity. Sometimes you just don't have enough attention to write down what you wanted to write down before it fades from memory. Shortcomings in any of these capabilities are going to affect your ability to take notes in class. Now, what does it mean when you say people are general purpose symbol manipulators? Basically, it just means that everything we know or perceived is turned into kind of a symbol in our minds. It's like a word is a symbol, like the word apple is a symbol for an actual apple. And essentially, general purpose symbol manipulators is that we're not working with physical things. We're working with these mental things, these symbols for things in the world. It's basically a code. And it allows us to be able to think about things and manipulate these ideas mentally. So a good example, once again, is like language. There's the apple example I just gave you. There's a physical object in the world. It's an apple. We label it as apple, but it's just an arbitrary symbol for the thing. And the word apple doesn't look like an apple or sound like an apple or anything else. But and different languages have different words for that same sort of thing. But the symbol itself is referring to a particular object that is shared across many cultures. Computers are also these symbol manipulators. The computer can display a picture of an apple on your monitor, but ultimately that picture is just a series of ones and zeros in the computer. And everything is one and zeros to a computer, and basically the symbols that we have, that's our representation of the world. Now, the information processing paradigm goals is basically, what we're trying to do if you're taking that information processing approach is determining the processing stages and storage places and how they work with each other. And you'll see this as we're going through the textbook, this sort of an approach to examining cognition. And you try and find relationships between these interrelated capacities that underlie performance. Now, the connectionist approach, we're going to be talking about this next week when we're dealing with connectionist models or parallel distributed processing models, neural network models. This is making an analogy between human cognition and the brain. So in this sort of a conceptualization of cognition, it's patterns of activation across networks of simple processing units. Once again, this too is rooted in structuralism, these little teeny elements combining to result in behavior and cognition. Basically, the connectionist approach is used to replicate findings of experimental and quasi-experimental models, but it uses connectionist models. What this means is that it's using an actual computer to take this neural network sort of approach and make these a computer program of neural networks and say, okay, if this is the way it works, here's how it should come out. And it looks at data where we've examined these things, using a different approach, an experimental approach, and say, okay, how well does it match human behavior? You're going to be learning more about this in, like I said, when we talk about neural networks, connectionist models next week. These questions you can actually tie it back to this because all of these questions are going to be on the test next week. There is no test this week. It's, 3 days. I don't expect you to learn all of it. Now, assumptions of the connectionist approach is that cognitive processes occur in parallel, which means that a lot of cognitive processes are happening at exactly the same time. And another assumption is that different patterns of activation account for various cognitive processes. So that's one of the reasons why we look at brain activity through fMRIs or PET scans or things like that. Different parts of the brain are active during different types of cognition. And then also it's the assumption that this knowledge is stored not in a single place, but as connections between a bunch of processing units, a pattern, so to speak. Now, the evolutionary approach focuses on understanding how evolutionary pressure shapes cognitive processes. Its foundation is in functionalism. The brain, this idea that the brain is designed to help people function in their environment. And evolutionary theory was a big part of the development of functionalism and incorporated into functionalism. The evolutionary approach, just like functionalism, uses these observational and experimental approaches through observation. So it uses both of those. Now, the assumptions of this approach is that the human mind has evolved. It's an evolved biological system. And evolutionary pressures in terms of finding mates, resource gathering, things like that have shaped our cognitive processes. And so we're very good at doing certain things that have evolutionary survival sorts of things. So one of the things that an example of this might actually be how we negotiate or, interact with other people, in terms of trading or in terms of, decision making. It's like, okay, this works this way, this works that way. In certain situations, we think very well or reason very well or make decisions very well if it was in the past sort of a survival mechanism. So basically, they're saying humans have these special purpose mechanisms that are specific to certain contexts in which behavior is occurring or classes of problems. And we're better at those than we are at more technological ones that only happened within the past 100 years or so. Now, the ecological approach has its foundations of both functionalism and Gestalt schools. I haven't talked about the Gestalt psychologists, though you are going to hear about them in pattern recognition and again in problem solving. Your textbook does talk about it. But the ecological approach has both of those. And essentially, they use naturalistic observation and field studies to look at cognitive activities shaped by not necessarily the environment, but specifically in the cultures and the context in which this activity is engaging in. And so you'll see how, in particular contexts, you reason one way, and then in other contexts, you might reason in another way. We're not going to spend a lot of time on the ecological approach, but you will see some of this pop up in various areas or topics that we'll actually be talking about. Okay, that's it. Kind of longish, but that's it for the history of cognitive psychology and then the paradigms and approaches that we actually take to it.